Okay, welcome back to chemistry YouTube land. This is just a short video I'm making for you to get a little bit of help with your day 7. This is just like extra practice for you to work through as you're getting ready for the test on Tuesday. Go ahead and take a second to pause the video just to check your answers on the sig fig questions. I'm not going to really talk about these. Check out, I'm inputting a link. I will go ahead and put a link into the video to this guy's channel. Tyler DeWitt has a lot of great videos that are chemistry tutorials on his channel, and I've had some students use those in the past that they say have really helped them a lot. So specifically the link I'm putting in is his playlist for significant figures. I think he's got like about 7 or 8 videos that teach you how to count sig figs and review how to round your answers and stuff. So if you're still struggling with this, then definitely check out that playlist. But we'll go ahead and go down here to the word problems, and I'm just going to work through these. So if you feel pretty good about this, you can just kind of fast forward the video till where I get to the answer, and you can just compare your answer to mine. If you need a little more help, then you can just watch the whole thing as I work through these problems from beginning to end. So for 11, we're finding the heat and calories to raise the temperature. So this is our unknown, is heat, which is the letter Q. We're raising the temperature of 0.05 grams. I know grams represents mass. And we're going from 20 degrees Celsius, that's T1, to 30 degrees Celsius, that's going to be T2. And we know the specific heat of the substance is 2.01 calories per gram, so that's the letter C, specific heat. So I know my formula I need is Q equals MC delta T. Some people call this MCAT because the triangle kind of looks like an A. If you want to remember it that way, you can. But you'll be given the formula on the test anyway. So our next step is we're going to go ahead and substitute in our numbers. I guess first we should go ahead and figure out our temperature change. Our delta T is equal to, we always subtract final minus initial, 30 minus 20.0, and leave the point zeros because that's important for sig figs, right? My change in temperature therefore is positive 10 degrees Celsius, so that'll be necessary to plug in down here. So first is my mass, 0.05. Second is my specific heat, which is 2.01. And then lastly is going to be my temperature change, positive 10.0. All right, and then I just go ahead and get my calculator and bang those numbers out. 0.05 times 2.01 times 10. Okay, and I get 1.005 for my answer here. So go ahead and write that down. Q equals 1.005, but I should round this. How many sig figs should I round this to? Well, when I look back at my givens, this only has one significant figure. Remember, leading zeros don't count. So this one has one sig fig, and we always go by the fewest. So this has 3, and this has 3, and this has 3. But since this only had one sig fig, that's what I need to round my answer to, is the first significant figure. So that's the whole number. So Q is simply going to round to 1. What's my unit here? Well, I look back here at my specific heat. It's in calories per gram degree Celsius. So I need to put calories here. 1 calorie is my amount of heat that was necessary. Okay, and it is positive. All right, let's go ahead and look at number 12. Sorry, gotta adjust my camera here. So number 12, we're looking for heat and calories to raise the temperature of 8 grams of mercury by 10 degrees Celsius. So let's identify my unknown as heat, the letter Q. 8 grams is my mass, and 10 degrees Celsius that's not the initial or final temperature. We don't know that. It just says we're raising the temperature by 10 degrees. So this is what we're going to call delta T here. We don't need to subtract anything. All right. So I'll write out my equation. Q equals MC delta T. All right. Well, my mass, we'll plug in first. I'll go ahead and do it right here. 8.00. And my specific heat is next. Well, you may have read this and been like, what do? I don't have a specific heat. Okay, this is where you need to really be careful. And on the test, I think there are some questions that are like this where you'll have a chart given to you, and that chart's going to have specific heat values for different substances. So sometimes the substance is really important. In this case, our substance is mercury, and we're looking for the heat in calories. So if I refer back to my chart on the previous page, right, this was given to you for a reason. You need these numbers. So I need to find mercury, right, and which specific heat do I use? I use the one in calories since that is what the question was asking for. So I'm going to use this number for number 12. All right, since we want the heat in calories here, okay, I'm going to use specific heat equals what was the number? Forgot. 0.033. So that's a given, even though it's not given in the question, it's given to you in the supplemental information in the chart. So therefore that plugs in next, 0.033. And then my final number is my temperature change, which is positive 10.00 Celsius. So then I go ahead and I bang that out on my calculator. 8 times 0.033 times 10. Okay, and I get 2.64 as my calculated answer. So I can go ahead and write that number. Q equals 2.64. And here's the problem. Well, I need how many sig figs? This is 3. This is 4. This is also given information right here in my chart. I was given the specific heat. How many sig figs is that? That's 2. So therefore I want to round my answer to 2 sig figs. So this is going to round to just 2.6. And then what's my unit got to be? Okay. Well, remember this specific heat, if you flip back to the previous page, this is in calories per gram degree Celsius, so therefore my unit for heat is just calories. So there's my answer rounded to 2 sig figs. All right, 13, looking for heat in joules to heat 20 grams of lead from 20 degrees to 150 degrees Celsius. So once again, we're looking for Q. We're starting with mass. This time we're given 2 temperatures, so I'll call that T1 and that T2. So I'll just figure that out real quick. 150 minus 20.0. So my temperature difference is going to be 130 degrees Celsius. And that's positive, right? It's going up from 20 to 150. So I'm going to need that, right? So this is my delta T right here. Okay, this is my mass. And, well, what am I missing? I'm missing specific heat again, so I should probably look. My substance is lead, and I'm looking for the heat in joules. So if I refer to that chart on the last page, I find lead, and this time we're finding joules, so we need to use the number from this side of the page, so it's going to be 0.13. So specific heat is 0.13 this time. So I write out my equation, Q equals MCAT, MC delta T, put the little P there, and then go ahead and substitute. So 20.0 times my specific heat of 0.13 times my temperature difference, which is 130. Right, and then I go ahead and plug it in. Okay, so my calculator gives me 338 joules. This time is going to be our unit. And then we just need to determine the number of sig figs to round to. So if I look back at my givens, I've got 3, 3, 3. All right, well, what about the specific heat? It was given to us as 0.13. Make sure that's accurate. Yeah, it was just 0.13 on the chart. So this has the fewest number of significant figures this time. That's 2 sig figs. So my answer, my 338, needs to be rounded to 2 sig figs. So the second significant figure is the tens place. So this would just round to 340 joules. Okay, so that's going to be your answer to number 13. One more calculation here. This time we're heating up, no, we're actually cooling down water. All right, so we want to know how much heat, that's our unknown, is released when 3.20 grams, that's our mass, cools from 83 to 54. So this is T1, this is T2. Real important, you always subtract the second temperature, the final temperature in the problem. So for my delta T, that's equal to 54.0 minus 83.0. So that is a difference of negative 29.0 degrees Celsius. So that's what I use for my delta T. Okay, and it says the specific heat for water is, if you don't remember it, I think it was given in the notes earlier, but we can go ahead and check over here. Okay, specific heat is, we want to know joules, right? So let's go ahead and look at, for joules it's 4.18. Okay, so I'll write that number in here. I'm not sure why this problem has you write it in. You could just look it up, but either way, it's joules per gram degree Celsius. All right, so we can go ahead and calculate Q equals MCAT, and we can plug in our given numbers. So 3.20 grams times specific heat of 4.18 times a temperature difference of negative 29.0, and then we go ahead and get an answer from our calculator. I already had negative 29 in there, so I'm just going to multiply that times 3.20 times 4.18. Okay, we've got an answer of negative 387.904. So if I check my significant figures, it looks like this time everything was given in 3 significant figures. So my answer is going to be the third sig fig rounded up. So it'll go up to an 8. So when I round it, it should be negative 388 joules. And that's my final answer. You may be wondering, what's the significance of a negative answer versus a positive answer? That simply means that if I have a positive answer, that this is how much heat is going into my lead, right? In this question, we're heating lead. So the lead is gaining 340 joules of energy, right? It kind of makes sense that if the temperature is dropping, like in the water, it's cooling from 83 to 54, then I end up with a negative number because this is how much heat is leaving my system. So if you left the negative off, you'd still get exactly the same answer, the same magnitude, 388. You would just get a positive instead of a negative. So that is important, though. Make sure you get the sign right on your delta T, or you won't get the sign right on your final answer for Q. Last part is just a little series of questions, but make sure you do know these, because I promise you'll have at least one of these on the test with multiple questions that refer to it. So you need to make sure you know basically everything about these graphs, these heating and cooling curves. So if I want to know the melting point, okay, what you do is you look at, you basically, if you get this on the test, what I would do is write down the states of matter right away. Your states of matter are the parts where the line is going up, or if it's a cooling curve where they're going down, but where it's changing, right? So at the first state of matter, you ought to know that's solid. The middle state of matter, is liquid and the final state is gas. Okay, so the slope parts are where you have pure states of matter, only solid, only liquid, or only gas at the end. The flat parts, see how they're in between the states of matter? Well, that's where you have a transition happening between those two states that are on either side of the flat part. So I know the transition from solid to liquid is melting, right? So I know at B, that's when my substance is melting. So if I want to know what temperature that is, I just extend. I can really just estimate, since it's a flat line, it's pretty easy to estimate, that the transition between solid and liquid is happening at 5 degrees Celsius. So there's my answer for number 1, or 15 rather. 16, boiling point. Well, I know boiling occurs when I have a transition or phase change between a liquid and a gas. So where on the graph is that happening? It's happening at the flat part for D, right? So again, I just kind of, if you really want to be sure on these, you can take like a straight edge, but I'm just going to estimate that that's occurring at about 15 degrees. This isn't the most accurate scale in the world, but it's good enough for our purposes here. We can say that boiling is occurring at 15 degrees. Okay. 17. Which letter represents heating of the solid? Okay. Well, that's got to be A, right? Heating, meaning the temperature is changing, right? And solid, that's the only substance present there. So that's got to be occurring at A. What represents melting of the solid? Well, we just talked about the melting points at 5 degrees. When is that happening on the graph? That's during the interval represented by the letter B, this flat portion of the graph right here. Okay. What letter represents heating of the gas? Well, that's going to obviously be E. Okay. At this, from basically right here upwards, the only state of matter present in my sample is gas. And it is heating. Last one, or second to last, number 20. What letter represents boiling? Well, that's going to be the flat part that's between liquid and gas. As I continue to add heat to the liquid, temperature stops going up, it converts into gas. That's occurring right here at the letter D. What letter represents PE? This PE stands for potential energy. Probably should know that for your test. So potential energy is the type of energy that we have to add or remove from a substance if we're changing its phase of matter. So potential energy, remember that this goes with the flat part of the graph. Okay, so where do we have flat parts of the graph where the temperature is not changing? B and D. Okay, if the question said, might even add this for those of you that have watched all the way to the end, which letter represents kinetic energy, right? So which letter represents parts of the graph where the kinetic energy is changing? Well, that's going to be your, remember, kinetic energy goes with temperature, right? So if I'm adding or increasing the kinetic energy, then what you're going to see on the graph? You're going to see the graph increasing. So what are the parts where it's increasing? Well, that's going to be A, C, and E. In other words, the parts that have one state of matter present. The non-phase change parts go with kinetic energy, so that would be A, C, and E. All right, so hopefully that video helped you out a little bit. If you watched all the way at this point, go ahead and leave your name and class period in the comment section, and I'll know that you're watching my videos, which makes me feel good about making them. And that'll be it for this lesson. So thanks for watching, and good luck on your test on Tuesday. Catch you next time.